how does it actually work? Well, you all had this experience. You have a fizzy drink, and the fizzy drink is in a bottle of, well, in a closed bottle or in a can. And if you shake it a little bit and you open it up, it sprays out. And why does it spray out? Well, it's because there's gas dissolved in the liquid. And once the liquid is under pressure, the gas stays in the liquid. There is no problem. As soon as you decompress it by opening the bottle or the can, the gas will start to expand. And that drives the liquid out, and it actually fragments the liquid. You get a spraying effect. And that's what happens with magma as well. And that produces tiny little particles, pyroclastic particles as we call it. And that is, for example, what then erupts as ash and other types of materials. So it's effectively an overpressured soda can that you may want to think of inside a volcano. Once you take the lid off, it will spray out quite violently. So the first phenomenon I'd like to talk about here is ash fall deposits. And here we have this Plinian eruption, a column of ash and hot gases rising up into the air, and it may go several kilometers high, and then it might spread out when it reached a certain level of buoyancy, and then the winds might also carry it away. So at Mount St. Helens, for example, there was total darkness within 360 kilometers of the volcano at the time during the eruption, because the density of the cloud is so intense that light doesn't come through anymore. The associated ash fall caused, of course, a lot of destruction. Agricultural lands was affected, and if the chemistry of the ash is not very good, then it's a poisonous effect. Basaltic material is usually quite good for agriculture, but the red volcanoes have higher silica, and it's usually not so good for agriculture. So here we then have dry volcanic ash, but if there's rainfall on top of it, the volcanic ash actually turns into a slurry or into a cement-type material, and that's extra harmful. So let me give you a few impressions here. This is actually from the eruption. I don't know if some of you know, but actually here I keep it in. This is ash fall. Here, a few images from the situation back in 1980 at Mount St. Helens. And here you see the cars in the lower left. This is not snow, this is volcanic ash. And what looks like a snowstorm in the top right is actually volcanic ash being blown around. And volcanic ash is not good for you if you breathe it in, because the tiny little particles, they will stick in your lungs. You will never get them out again, and it can cause silicosis. So the particle density in those situations is so high that you can only really work there with a mask. And back in the 80s, nobody really told anyone about that. So nowadays we know a lot more. So it's not very healthy to be in those situations, and ash fall has severe consequences. So here's a few more impressions of ash clouds back from Mount St. Helens in 1980. And this gentleman here, he was smart enough to put a mask on. But as I said, if we have then ash mixing with water, it becomes like a cement or a concrete. And here we have that letterbox there being, well, partly engulfed by this slurry, and the car driving there, well, it creates an ash cloud in itself. And this means very high particle density in the air, very bad for humans and animals, of course. So here's the ash cloud from Mount St. Helens, and this is the travel speed of the ash cloud. And as you see, it actually traveled almost 1,000 kilometers, and at 9:15 in the morning, it was about 50 kilometers away from Mount St. Helens. And by end of that day, at 18:15 in the evening, it had traveled something like 1,000 kilometers to Idaho Falls. And is, of course, a wind factor here. If the wind comes in one direction, it, well, blows it in that specific direction. If the wind goes another way, If the wind would have come from the other side, it would have blown out onto the ocean and would have been far less devastating for humans and animals in the area.